So 9.4 is called the comparison test. Um, this is taking a series that we know converges and comparing it to a series that we don't know if it converges or not. So we can test convergence on some different series, based on the integral test, or if it's geometric or a p series, then we actually know how to find the sums of those. But if we know a series converges or diverges, and we know some other things, then we can compare them. So theorem 10 says let uh, this sum and this sum be two series where uh, the sequence a sub n is stuck between 0 and b sub n. So the terms of the series, the sequence is always between 0 and the other sequence b sub n for all n. So, so the obvious thing then is if b converges, then a has to converge. Okay. So and this is not just b, it's the sum, it's the series. If the series b sub n converges, then the series a sub n also converges. But then also if the one in between, the one in the middle, if it diverges, if it blows up to infinity, then the one on the outside, um, the sum of b sub n should also diverge. So if the one on the outside converges, then the one on the inside has to converge. If the one on the inside diverges, then the one on the outside also has to diverge. So let's look at this series. So we have 1 over square root of n minus 1. So we're going to call this, oops, let's call this a sub n. All right, and so is there something we could compare it to? Well, I know b sub n equals 1 over square root of n. That's similar, right? So do these have a relationship? Well, I know that since I'm lowering the denominator here, I'm making this fraction bigger. So this has to be greater than or equal to square root of n. Right? Now, the sum of 1 over n to the 1 half, I know that this diverges by the p-test. Remember the p-test? The p-test says that if this exponent here is less than 1, then this thing is gonna diverge. If it's bigger than 1, then it will converge. If it's equal to 1, it also diverges, but this is less than 1. So p equals 1 half is less than 1, so this is going to diverge. So, and these are positive too, right? So I've got 0 is less than or equal to 1 over square root of n, which is less than or equal to 1 over square root of n minus 1. I know that this diverges. That's the one in the middle. That means this guy, the sum, I should say this, the sum, the series diverges. So this series must also diverge. Actually, this is from 2 to infinity. That's okay. From 2 to infinity, this guy's going to diverge because this one diverges. Right, the next one is n minus 1 over n to the fourth plus 2. So let's break this up into two separate ones. All right, so we'll just take these separately. Um, n over n to the fourth plus 2, can we compare that to something? Yeah, let's compare it to n over n to the fourth. Right? So which one's bigger? If I make the denominator bigger, I make the fraction smaller. So this one's smaller than that one, right? And this is equal to 1 over n cubed. So I know that 1 over n cubed, that the series converges. So this series converges by the p-test. The p-test says p is equal to 3. That's bigger than 1. So that means this converges. And this is less than or equal to or greater than or equal to 0. So this guy is stuck between 0 and 1 over n cubed. And the series 1 over n cubed converges. So that means this one also converges. So this one converges. What about the other one? So let's take 1 over n to the fourth plus 2. Again, that's got to be less than 1 over n to the fourth, right? If I make the denominator bigger, makes the fraction smaller. And I know that this converges by the p-series test again. The series 1 over n to the fourth converges by p-series, p-test. Right? P is equal to 4. P is equal to 4, and 4 is bigger than 1. So it converges. So both of these converge. So this guy converges. Again, we're not finding the sum. We just want to know, does it converge or not? All right, so this one, let's call this 1 over n times 1 over 3 to the n. All right, so let's compare 1 over n times 1/3 to the n to just 1/3 to the n. Can we just compare those two? If I'm multiplying by 1 over n, if n is 1, it doesn't change it. But if n is bigger than 1, we get to 2, 3, 4, and 5. Multiplying by 1/2, 1/3, 1/4, it's going to keep making this term smaller. So that means these are stuck. This one is stuck between 1 over 3 to the n and 0. They could be equal, right? If n is equal to 1, they could be the same. But after that, it's between. All right, so the sum n equals 1 from n equals 1 to infinity of 1/3 to the n. This guy is a geometric series, right? And r here is 1/3. And the absolute value of that is less than 1. It's between -1 and 1. So that means it converges. We'll call it geometric series test, right? You find r. Here r is equal to 1/3. So I know that converges. So this converges. This guy's stuck between. So that means this series converges. All right. So whenever you see sine, you want to use the fact that sine is between -1 and 1. What if you square sine? if you square sign, then it can't be negative at all, right? So this has to be between 0 and 1, right? If I square sign, it can't be a negative number. So it could still be 0. If I plug in, if I take sine of 0, I get 0, right? So it's stuck between 0 and 1. So if I divide these by 2 to the n, this is like the squeeze theorem, right? I mean, all of this comparison stuff is like the squeeze theorem. If I divide by 2 to the n, 1 over 2 to the n is 1/2 to the nth power, because 1 to the n is 1. So that's geometric. R is 1/2. It's between negative 1 and 1, or the absolute value of it's less than 1. So this converges. So that means, since this one is stuck between 0 and a convergent series, then this series converges. All right. So again, I got cosine. So cosine is between negative 1 and 1. We'll just start with that one. We're not squaring cosine, right? If I add 1 to it, then I'm going to get 0 and 2, right? And then if I divide both sides by n squared, and I know that this is a p series, p is equal to 2, that's bigger than 1, so this converges. The series from n equals 1 to infinity of 2 over n squared converges by the p-test. And this one's stuck between them, so this also converges.